Yes, this time let's talk about reference counting among the scissor collector methods. In this way, an important concept is the concept of rebinding. Actually, it was expressed in difficult words, just the number of references to a specific object. I'm talking about the logic of increasing or decreasing. So, for example, let's say we have this class called object, and we have a pointer variable called object field. If you add a non-object here, you're substituting this point now. Then increment the reference count for this B object, this time in a situation where Mercy is on the line. There is no A. Then we set the reference count for the previously inserted B to 0, and increase the reference count for the newly inserted A. Now then, if we decrease the reference count by 2B now, and if this becomes 0, we will go and release the object called 2B at that time. Now, at this time, when I release Evie, I not only release the obesity, but the object called Evie that I want to release now is again inside it. It is a bit ambiguous to say that this child and this B object is also referring to other point variables. There will be. Now this one that's substituted here, it also reduces the reference count for objects, because it disappears, but similarly, if the pointer gate named ID becomes a station again, this process that was just carried out will be carried out for ID class, and this process will be initiated. Now, the reference counting method has a fatal drawback. What is that? In the case of circular references, the object can now not be released from memory. Now, for example, we have this object called root. This refers to the object called A. He refers to B and B refers to A. Now, but in this situation, this root and cut off the relationship between a OK then existing. If this root is now referencing a like this, the reference count for A would be E, because there are roots, and B referencing A. Now, if you cut off the relationship like this, reference counting will now work, because 2B is the only one biting A. But the problem is that this root is 2A from the example now. It means unricher. Even though it's an unreachable object, that is an object that I don't use, it can't be repaired simply because the reference count is not 0. Now you're going to make a profit, right? In this way, the problem of circular reference fundamentally exists. So if we look closely at how we can solve it. First, apply reference counting. Then, like this, there may be cases where RIC occurs due to circular references, right? To cover this, we will perform an additional Gabesi collector once more. So, for example, if you were to perform the mark income one more time, you would now look at the root as the standard. Now don't you reach a since A can't reach it right now. If you make the mark bit about it into a pulse and proceed so that the sale can be released at the import stage, you can make up for the shortcomings of the reference counting method? Yes, the final explanation is that shortcomings can be overcome in this way. Now let's see how I approach 2GC in a real game engine to further understand this process.